The cosine rule is a second rule related to non-right angled triangles that is actually derived from exactly the same triangle as for the sine rule, but we're just going to go through a slightly different process. Just as before, we're going to draw the perpendicular line to the base and call it H. But this time we're also going to start thinking about lengths along this side. So in particular, I'm going to call this distance X. And I'm going to work out what this distance here is anyway. The full length of this line is B, okay, from here to here. Again, that's by convention, referring to the opposite side to big B as being little b. So this distance in here has to be B take X. We call this side A by convention, and this side gets called C. And what I'm going to do is I'm going to consider Pythagoras' theorem for each of these two triangles. So in the left-hand triangle, I'm going to have that C squared equals B minus X all squared plus H squared. And I'm going to go ahead and expand those brackets. I get B squared minus 2bx plus X squared plus H squared. Now, I'm also going to think about this right-hand triangle. It's a little simpler, doesn't have this B minus X thing going on. Here we have that A squared equals X squared plus H squared. Now, just have a look at the two sides here. We've got that A squared is X squared plus H squared. And we've got an X squared plus H squared appearing in the left-hand thing. Now again, as before, we introduced H and X, so we want to try and eliminate them. So this is a really easy way to eliminate this X squared and H squared. We can just replace it with the A squared. So here I'm just going to go that C squared equals B squared minus 2bx plus A squared in place of that X squared plus H squared. Now I'm going to rearrange this. Just to be a little bit nicer. The only thing left to do now is to eliminate that X that we have there. And the way that we can do that is we can start considering this right-hand triangle. So what I'm going to do is I'm going to think about what is X going to be. Okay, one way is by this Pythagoras thing, but we've already done that and led to this. So instead what I'm going to do is I'm going to relate it to my trig ratios. X is an adjacent side, and we know that cos of a particular angle, so in this case capital C, is equal to adjacent over hypotenuse, X on A. And if I rearrange that, I'm going to get that X is equal to A cos C. So that is what I'm going to replace in here for my X. So I get C squared equals A squared plus B squared minus 2b A cos C. And just a little bit of housekeeping. Normally we write letters in alphabetical order, so I'm going to swap these two around. So that I get C squared equals A squared plus B squared minus 2ab cos C. Now, this is what we call the cosine rule. And if you have a look at it, you'll notice a couple of things. One is that part of this is very familiar to you. This part here is exactly Pythagoras' theorem. The deal with the cosine rule, though, is it has this additional factor, this minus 2ab cos C, which is kind of like a correction factor. This takes into account the fact that we don't have a right-angled triangle. Normally, this would be Pythagoras and only be able to apply in a right angled triangle situation. Here we have a factor that just corrects for that non-right angledness. And when we get to class, we're going to look at this a little bit and talk about why this is so closely related to Pythagoras' theorem. And in fact, you can get Pythagoras' theorem from this result.